go for the most optimal solution using sorting. So let's understand how we will do it. So I will take an array 3, 4, -1, 1. I will give index to it. So here what I am expecting, I will tell you. Give the index to it 0, 1, 2, 3. At 0th index I am expecting 1. So I will keep doing swapping until I get 1 at the 0th index. Then I am expecting 2 at index 1. So I will keep doing swapping until I get 2 at the first index. I am expecting 3 at the second index. I will keep doing swapping until I get 3 at the second index. And similarly, I want 4. I expect 4 on the third index. So let's do it. So on the I. So 3, where am I expecting this 3? At which index I am expecting this element 3? At second index. So I will move this 3 to second index and move this -1 to 0th index. Now it is having -1. So -1 is a negative number, and we are not looking for negative number. We are looking only for positive number. So I will move my I to the next index. So here it is 4. So at which index I am expecting 4 element? I am expecting 4 at third index. So I will move this 4 to the third index, and I will move this 1 to the first index. Now where I am expecting this element 1, at which index I am expecting it? I am expecting it at 0th index. So I will move this 1 to 0th index and -1 to the first index. Now it is a negative number and we are looking only for positive numbers. So I will move my I, and what I am seeing here, 3 is at the right index. Let me change the color. Okay, and now I will move my I here. Now here also what I am seeing, 4 is at the right index. Then I will move my I. Now I will again iterate this swapped array. So, and I will look whenever I plus 1 is not equal to array of I, it means I plus 1 is the answer. So at 0th position I am seeing 1, which I am expecting. At first index I am seeing -1, but I am expecting 2. So 2 is the answer. That is the first missing positive number. So we will come out of the while loop. Okay, now let's code it. So int n equal to a dot length, and for int I equal to 0, I is less than n, I plus plus. While it will be nums. While nums of I is greater than 0 and nums of I is less than equal to n. So it should be in the range, okay, from 1 to n plus 1. Okay, here it should be n. For n plus 1 we will see later. And I is not equal to, I plus 1 is not equal to nums of I. So it means it is not expected. So we will do, I will take x nums of I, and I will check whether is at the right index or not. Okay, so if a dot x minus 1 is equal to x, so it's at the right index. Okay, now else we will do the swapping. So in temp I will take the x minus 1, and at a x minus 1 I will put the x element, and at a of I will put the temp. Okay, now I will iterate again, I is less than n I plus 1. Okay, now if I plus 1 is not equal to, here it will be nums, here also it will be nums, and here also it will be nums, here also it will be nums. Okay, if is not equal to nums of I, it means it's not at the right position, it's the missing number, it is the first positive missing number, so we will return it. So there is one case here, suppose let's see that case. If 1 2 3 4 5 is the array element, so every element is at the right index, 0 1 2 3 4. So 0 plus 1 is 1, 1 plus 1 2, 2 plus 3 3, 3 plus 2 plus 1 3, 2 3 plus 1 4, and 4 plus 1 5. So in this case, so we need to handle this case. Okay, so what I will do, if return n plus 1, in that case we will return the n plus 1. Now run this. While nums of I, okay, what is the issue here? Okay, I am missing here the I element, I index. Now run it. Now it is accepted. Let's submit it also. So it got accepted. So here what is the time complexity? And since here it is, we are iterating n and swapping it, so here the time complexity will be order of n only, and space complexity, since we are not using any space, so it is order of 1, since we are swapping in place. And this solution is also on the grounds of counts out only, but it is in place.